Excellent. Like indiscriminately.
Okay, thanks guys.
There is a...
All right, so I guess what I wanted to do was just set out an agenda for the Microservices Meetup group. So what are the sorts of things that we want to talk about in the future? I'm also going to set the stage a little bit. So who am I? So my name's Saul Caganoff. I've been doing distributed systems for about 20 years. And slowly getting better at it. So my background, I've done a lot of work, mostly around integration, service-oriented architecture. I got into integration when it was called this great new thing called EAI, which was Enterprise Application Integration, which eventually morphed kind of into SOA. I've done quite a bit of event processing, so complex event processing, event-driven marketing, those kinds of applications. Some business process management, service orchestration, etc. Prior to that, I spent a few years doing CAD and GIS, and that's actually what got me interested in distributed systems. I worked on a big project at Telstra. It was the world's biggest GIS database. It was their whole network map for the whole of Australia. It was a distributed database in 70 locations. 1 terabyte of data, the world's biggest GIS. This was in the early 90s. And managing all of that, it was all file-based. Managing that was a complete nightmare. And so we built a relational back-end for it, and I was the lead engineer on that. And that got me into client-server and TCP and streaming protocols and all of that stuff. And I never sort of looked back from there. Prior to that, I spent some years as an astronomer. That's where my introduction to IT, to programming, was Fortran, modelling data, image processing, all of that sort of stuff. I'm the CTO at Sixtree. We're a consultancy here in Melbourne and Sydney. We just do stuff, interesting stuff. I'm an editor at InfoQ, so I cover APIs, SOA, architecture, and a bit of microservices at InfoQ. In 2007, I started blogging. I had the hopelessly naive and altruistic domain name of soabloke.com. I don't really blog there anymore. I blog at Sixtree, and my Twitter handle is scaganoff. In fact, on pretty much all social media, I'm scaganoff. There's not too many of us around. So, as an overview, I'm going to step back. I think this is a really interesting time in IT. My origins in IT are around the 80s when we were moving from mainframes into client-server systems. I've been through the whole web thing, all that was pretty exciting. What's happening with the cloud is really as big. It's every bit as big as the shift from monolithic to client-server architectures. That shift, it created empires and it destroyed empires, and we're seeing the same sorts of things happening again. So I'll be sort of looking at microservices in that kind of context a bit. A little bit of reflection. We've been through this a couple of times before. As I said, we're gradually getting better at it. So what have we learned as we go? And then what's happening and where do we look forward? So a bit of philosophy. Back at uni, I did this course on epistemology, which is the study of knowledge. How do we know what we know? How do we gain knowledge? How do we know that our beliefs represent something that's true and good? How do we know that we're operating out of knowledge rather than luck? How do we know that agile works better than waterfall? Might be self-evident. In some organisations or places it may not be. How do we know that microservices might be better than monolithic architectures? So these are all good foundational questions. So some of the people who've looked at this idea, this epistemology thing over the years, there's a guy named Karl Popper who came up with, he effectively invented the scientific method. He said that you can ask a question, you can form a hypothesis. You can never prove the hypothesis true, you can only falsify it. So if we said all swans are white, to prove that all swans are white, you have to go and audit every single swan in the world. And obviously that's an impossible thing to do. But you can falsify it very easily by getting on a sailing boat and going to Perth and finding a black swan. hence the term, the black swan event. Totally unexpected event that falsifies a particular paradigm or belief. So theories can never be proven, they can only be falsified. We can never say microservices are the best. We can say, well, microservices maybe don't work, or waterfall doesn't work, etc. But even then, that's kind of a bit flaky. That's a very simplistic view, basically. So in the 60s, this guy named Thomas Kuhn wrote a book called The Structure of Scientific Revolutions, where he said, well, actually, scientists don't quite work like that. The way scientists work is they'll come up with a theory and they'll stick to that theory and they'll work within that theory and they'll test the theory and they'll find problems with the theory, but that won't deter them. They don't just give up because there's a problem. They'll keep trying to find ways to work around it. And eventually, they'll either strengthen that theory and keep going, or eventually the problems build up and they say, well, that doesn't really work. There's a better theory over here that fits better. So he termed this idea as a paradigm. Now, paradigm might sound like a wanky marketing word. Lots of marketers use it without knowing what it means. But a paradigm is a set of rules, tools, ideas that scientists use to define the boundaries of what they know and what they work within, and to describe how they behave within those boundaries. Okay? And a paradigm sounds a lot to me like an architecture or a platform in IT. Okay? So we might think of a three-tier architecture as being a paradigm, a way that we work in building applications. We've got a database, we've got a middleware tier, we've got a UI front end, and that's the way we've been building applications for a while. We keep building them over and over. Sometimes they work, sometimes there's problems. Okay? So that's the Kuhn's view of scientific progress, of how we progress with ideas and frameworks. There's another interesting guy, Paul Feyerabend. He wrote a book called Against Method in 1975. This guy's an anarchist philosopher. He said, there's no method. It's all marketing, basically. Sometimes we think that IT works that way as well. These guys all talked about the classic example of a scientific revolution is moving from thinking that the Earth is at the centre of the universe to the sun being at the centre of the universe. And this is called the Copernican revolution. And we tend to naively think, well, they all woke up one day and some guy wrote a treatise that said, the Earth's not in the centre of the universe, the sun is. And everyone went, of course. But in reality, it wasn't that simple. It took them 150 years, from 1543 when Copernicus wrote his treatise to about 1687 when Newton wrote his Principia, for it to all pan out. And we can see that in real paradigms. We can see that in IT. Mainframes to client-server to three-tier architectures didn't happen overnight. It happened over probably about a decade. And we'll see the same thing. This cloud thing, it's going to pan out. We're going to have hybrid clouds. We're going to have on-premise. We're going to have mixtures for the next 10 years at least, right? Same thing, microservices, if and when it has legs, it'll pan out over years. So we've got lots of time to practice and come up with refinements of this. So the Copernican revolution, in the olden days, people thought the Earth was the centre of the universe and the planets revolved around the Earth. And that was a nice view. But the planets kept doing these loop-the-loops in the sky. So they had to explain that some way. And the way they did it was this guy named Ptolemy in 50 AD or so said there's epicycles. The planets don't just orbit the Earth, they live on little wheels as they go around the Earth. And that was fine when it started, but then gradually they discovered that as they got more data, they had to add more wheels on wheels. And in the end, they ended up with hundreds of wheels, thousands of wheels, and it was just a spaghetti architecture, if you like, for the universe. So 1543, this guy named Copernicus published a treatise, and he kept it secret. He didn't publish it till on his deathbed, where he came up with a heretical idea that the sun was the centre of the universe, The Earth goes around the sun and all the planets go around the sun. And that explained the epicycles, the loop-the-loops that the planets did. But look, it didn't explain everything, okay? If you took the data and you compared the data, it couldn't differentiate between the two theories. It was Galileo that really pushed a lot of this idea. But really, he was a marketing guy. He was really good at marketing, and he pushed the Copernican idea, and everyone glommed onto it, even though the data didn't really support it so much. And you can see parallels. You know, in this migration, some people are doing waterfall, some people are doing agile. Which one's better? Well, it depends. You can't tell from a single project which one works best. You can only tell in aggregate over a period of time, over a statistical sample, over particular, taking into account various cultural differences around how people work. Same thing in physics, right? We needed better data. This guy named Tycho Brahe went out and measured the planet's positions very accurately. This guy named Kepler came along and said, actually, the planets don't orbit in circles, they orbit in ellipses. So that's slightly different. And that gave us all the empirical information that we needed. But it wasn't until Newton came up with the idea of gravity that we then had a theoretical framework to hang that on. So that whole process of shifting from Earth-centric to sun-centric, 150 years. Okay? So how is this relevant to IT? Well, first of all, at least when you're looking at planets, you can measure their positions and you can compare that with theory. Okay? What do we compare with in IT? We're sort of looking for truth, we're looking for beauty, we're looking for business cost effectiveness, we're looking for agility. It's very hard you can't measure productivity, Martin Fowler tells us so it must be true. It's very hard to measure quality. So how do you measure truth or correctness in IT? Software is a social process. You can't separate the method from the culture. The organisational change means you're not doing it properly, right? If you come along and say, well, we tried this agile thing, it didn't work, well, you're not doing it properly. That comes back to the falsifiability idea. You can't falsify a particular way of working, okay? So it takes a long time for knowledge in IT to converge, and in that time, the tools that you use and the technology you use moves on. So we might never converge, okay? Sometimes you might think, after a hard day at work, you go, IT is merely fashion. It's really just marketing. But we've got to have some basis for measuring ourselves and improving, I think. So part of Kuhn's paradigm shift is that you get this life cycle of a shift. You get a crisis building up. So the crisis is discrepancy between theory and fact. The crisis in IT is the inability to achieve the things that we want to do, whether that's cost effectiveness or agility or what have you. It can also be a change in the social and cultural climate, and we can see that. There's lots of things changing around us. Businesses are changing, the requirements for IT are changing all the time. You go into this kind of crisis mode where there's pressure to change, but there's also pressure to stay put. There's a lot of vested interests in waterfall methodologies, a lot of vested interests in sticking with relational databases and monolithic architectures and all of those kinds of things. It takes a long time for failures to build momentum and create that critical shift that we have. And then when the shift happens, you get new candidates. Sometimes there can be multiple candidates emerge. So it might not just be microservices, it might be other approaches that are around there. I mean, distributed systems, BitTorrent is a distributed system. That's perfectly good at doing what it does. There's lots of peer-to-peer type systems that might be alternatives to what we need to do in some fields. And often the old paradigm doesn't die out completely. How many COBOL programmers are still out there?
I worked with a bunch of them at Suncorp, but not anymore.
So we've had these application architecture shifts in the past. So I think what we're looking at with microservices is it's potentially a shift in the paradigm of how we build applications. Okay, so if we look at in back in the 1980s. So in the 80s, I was at uni. We had a whole department, 150 people, all hanging off a VAX 11780. We all had these little VT100 terminals on our desks, and it was slow. It was the crisis there was the scarcity of compute resources, right? Everyone was hanging off one machine. Even when they upgraded to 75 megabytes of memory, which should be enough for anyone, that got a little bit better, but it wasn't so good. I did a lot of my work from midnight to dawn, or at night. Two reasons. One is 2JJ got broadcast in Canberra at midnight to dawn, so I could listen to some decent music, and the VAX was faster, right? So my social inadequacies are all due to the scarcity of compute resources on the VAX. Right? So we had this crisis, scarcity of compute resources on the mainframes. Business agility was another big thing. Why can't these COBOL programmers do the things that we need them to do in the time we need them, right? The enabler, so the thing that came along to enable the shift was the emergence of PCs and mid-range computers. So almost overnight, these Sun pizza boxes came out. They were about the size of that, the Sun 2s or 3s, I think they were. Only $15,000 for a Sun workstation. These IBM PC ATs came out. My supervisor started running his smooth particle hydrodynamics simulations on his PC. Didn't have to bother with the VAX. We had this guy from Canada show up one day with an Amiga. He did all his graphics and everything, data analysis on the Amiga. He never had to, unlike us, so if we wanted to do any graphics, you had to book time on this thing called the ARDS, which was like a TV screen, or this Tektronix 2010, which was like an Etch-a-Sketch on steroids, basically. So these guys with the PCs, this was shadow IT in the 80s, was you had a PC or an Amiga on your desk. And you didn't have to line up for batch time or ARDS time, etc. So the emergence of mid-range or desktop systems, and the impact was, well, there are a lot of impacts, right? But one impact was the dollars shifted from hardware to software. A lot of big hardware companies went out of business. Sun Microsystems became the big guy on the block, and hardware margins shrank. People started making money out of software. So that's when companies like Oracle emerged. Prior to that, no one really made any money out of software, and a lot of organisations built their own software. The build versus buy equation was very different. Okay, fast forward to 1995, World Wide Web. There was a crisis there as well. It was content distribution. You go out and you'd buy Windows or you'd buy Word or something like that, and it'd arrive on, first it was like 36 floppy disks, but then it became CDs. You had people like Microsoft trying to sell you Encarta encyclopedias on a box full of CDs. Distributing programs, content, etc. was kind of difficult. The other big thing was e-commerce. Everyone was talking about e-commerce in the early 90s. Who's heard anyone say the word e-commerce in the last year? We don't say it anymore. The word's disappeared because it's just the way we do business now. It's ubiquitous, it's become part of the wallpaper. But it was a big problem back then. How do we get people and companies to buy things from each other using this thing called the internet? The World Wide Web, yeah, 95. So the enabler was HTTP, HTML, etc. And the impact, among others, was that dollars shifted online. So now we've got a current shift. So I see this as being the new shift now, this cloud thing. The crisis is one of agility. I think there's a couple of different crises, but the main one that we run into all the time is agility. The business, once again, same as in the mainframe days, why can't these IT guys do things as quickly as my business needs them to do? Okay. We've got a couple of enablers. Commodity hardware, so Google can go out and buy 10 million Linux boxes and afford it. Virtualization, service architecture, DevOps, all of those things. The impact? Well, Time will tell, but there will be an impact. I'm pretty sure of that. This is all happening amongst a lot of different shifts. So the big shifts are physical to digital, right? Netflix is not shipping CDs in the mail anymore. They're giving you streaming video over the network. Local to global. A little company in Melbourne can sell its stuff, sell its services to the whole world. And assembly line to TQM, that's sort of driving some of this waterfall to agile. As we automate the grunt work in all fields, not just in IT, but in manufacturing, as we automate the easy things, it's the hard things, the craftsmanship, that becomes high value. So when we move to things like agile and software craftsmanship, that's really reflecting a broader shift of the separation out of the automation and then the hard stuff. Okay, so the current crisis, I've talked about business agility and the speed of change. And some of that's related to the way we build our applications. You might have heard the term the big ball of mud. Google that. There's some good discussion out there about this concept of these monolithic applications which are too tightly coupled and too hard to change. Okay? And that's directly what microservices is trying to address, that big ball of mud. Scalability. With a global user base, how many people here are hacking their routers to hook into Netflix so they can watch Netflix?
I think I proved that in my presentation.
Yeah.
Yeah.
So a global user base wants to be there. We want to serve that global user base. That means how do you scale, right? And there's two flavors of scalability. There's scaling out. There's differential scaling, as you talked about. Some parts of our app don't need to scale as broadly as others, okay? The write parts maybe not so much, the read parts a lot. And then there's elastic scaling. We want to scale out when the traffic is there and then scale back in so that we save money. There's also commodity versus differentiation. People are looking to IT to differentiate their services. And that doesn't mean they want to build all of their systems themselves. They want to build some systems and do COTS for other functions. Okay. So the monolith. Have we been working with the wrong level of abstraction? We've been building up these off-the-shelf applications, 3-tier architectures, over the last 30 years, 20 years. They're getting bigger and bigger and they're becoming very heavyweight. The bigger the application becomes, the harder it is to change. SOA has sort of been around for, 15 years now? A little bit less than 15, 12 years. Services feel like the right level of abstraction to work with. I've certainly felt that as a feeling basis, if you like. But it doesn't seem to work very well with our systems that we have at the moment because we've still got these big monolithic systems in the background and we put service facades over them, but there's still lots of ETL that needs to happen in the middle. There's still lots of synchronization that has to happen. Okay, and there's very coarse differentiation between commodity capabilities and defining capabilities. So Gartner talks about this pace layering. How can we do pace layering if we built the whole organisation around a big SAP instance, for example? You can't differentiate if you're just running everything in SAP. Okay. There's this thing, I call this the leap of faith, right? We've got the business up here, we've got the value chain, what the business does, and we've got business capabilities that support that value chain. And we go out there and we buy these applications off the shelf. We put together RFPs and feature function matrices, and we go, I'm going to go out and buy that app. I'll spend $40 million on bringing it in, and then there's this big gap between what I need and what it gives me. And we tend to fill that gap with customization, which creates a bigger ball of mud on top of an underlying ball of mud. The layered SOA approach sort of addresses that by saying, well, let's put a layer of services over there and business processes which bridge to the capabilities that we need. So that's kind of, I guess, the paradigm, the SOA paradigm we're working in now. how does microservices fit into this? And I think what we're aiming for is microservices that will be able to reach up to this level and directly support the capabilities that the business needs. So what are the opportunities? We talked about crisis. So crisis is building, there must be better ways of doing this stuff. What's the toolkits that we can use to leap into the next paradigm, if you like? So there's cloud, we've got scale, we've got low cost, we've got agility, we've got abundance, and what the Netflix, Adrian Cockcroft talks about as ephemeral infrastructure. We've got things as a service. Services as a service is a bit of a buzzword around at the moment. We want to be able to buy services, not software. We want to be able to bring in capabilities from the web, compose them together to support the business requirements that we need. Okay? We've got lots of NoSQL. Databases are not big, expensive things anymore. They're very cheap, they're very small, they're very malleable. There's lots of different flavors. On a network database, I go Neo4j. On a document database, I go Mongo or Elasticsearch. I'm on a relational database, I go for NoSQL, SQL Server or something like that. Continuous delivery, that's making change automated, making change easier. Agile, rearranging the way we do things, bringing small productive teams into play, breaking down the barriers between development, deployment and production that create a lot of latency at the moment in current organisations. So in DevOps, removing those barriers from conception through to production, we should be able to do that in a day rather than a year. I think some of this is related to what some people have been talking about, the composable enterprise. So this guy, Jonathan, I've forgotten his name now, the CTO of Warner Music Group has written a blog post about the composable enterprise. The idea of being able to take capabilities and mix them together to build an agile organisation. So some of these examples are people like Amazon and Netflix and Warner Music Group. But the interesting thing, these are all developers, these are all providers. So they're all building their own components and using them themselves. But I think in the future, the mainstream, most organisations will be consumers. They'll take a bit of Salesforce, they'll take a bit of Magento, they'll take a bit of Zora, and they'll mix them together to run their businesses on cloud applications, on these SaaS applications. So how do we consume commodities, SaaS, versus building our own systems, or maybe a mixture of the two? And I think that plays into the microservices world as well in some way. So one of the other things we find is that the first instances of a new paradigm, and that's what I'm arguing, that we're already seeing this new paradigm in play. Okay, first instances of the new paradigm often look like the old paradigm, right? The first cars looked like horse and buggies. The first TVs looked like radiograms. And if you look at Salesforce.com, it looks a lot like Siebel that's kind of up in the cloud. I hope I'm not stepping on anyone's toes there. But if we look at something like Netflix, Netflix is almost unimaginably different to Salesforce, at least from the outside world. The other thing is Netflix an application or is it an enterprise? So we're seeing with Netflix the traditional boundaries between boxes and applications are kind of dissolving, and it's really just becoming this platform that people build on. Okay. Right. So we've been here before in a certain way. So we've had a lot of goes at distributed systems. When I got involved in doing my GIS client-server thing, I was using some Sun RPC. So, and that was hopeless. It was very chatty, very round-trippy. It didn't work very well. I ended up throwing that away and building kind of streaming, asynchronous message passing type interfaces, which gave me a lot more a lot less user latency, at least in terms of what people saw. There was a big deal around Corba, and Microsoft had DCOM, and they're all trying to push this idea is that we could build objects and then we could distribute them at runtime, and that was a big thing around 1995, 97, and it all kind of fell in a heap. But a lot of that stuff was really reflecting the way we were building our applications. So distributed objects was because object-oriented was the flavour of the month. It was the brand new paradigm. And distributed systems would really just be objects, and you just put them across all your different systems. SOAP came along. SOAP was actually Microsoft's attempt to derail Corba, and it worked brilliantly. Okay, so both the dot-com bust and SOAP kind of derailed Corba, and everyone sort of forgot about it. Corba was very heavyweight, and it kind of collapsed under its own complexity. Of course, all the Corba guys then jumped onto SOAP and web services, and web services became Corba with angled brackets, and so that kind of ended up collapsing under its own weight, if you like. REST is obviously a reflection of the way we do the web, but we want to make it work for bots. Some of the things we haven't really talked about in the last 20 years is events and asynchrony and concurrency, and that's getting a new lease of life. And to a certain extent, some of the things we're seeing in Go with the CSP way of programming, Go and Erlang with its actors, is a bit of a return to some message passing paradigms that were around in the 70s on the mainframes as ways of handling concurrency. So we know that there's a lot of challenges with distributed systems. I should have probably said challenges rather than problems. Problems sounds bad, challenges are good. Right? So some of the classic problems, serialization. Serializing your objects or your state into something that can be sent to another machine, that's always been a problem, and we're making inroads there. Interface contracts, service discovery. Waldo et al. Published a paper around in the early 90s about the fallacies of distributed computing. We're getting our heads around that. Okay? State management and consistency. We talked about event sourcing. How do you replicate state of one system across to another? Some of the new issues we're running into, management of large distributed deployments. How do you get visibility into large distributed deployments? How do you respond to failures in there? Respond so that there's minimal downtime, or respond so that there's graceful degradation. Resilience, change, versioning, interface changes, etc., and coordination. These are all interesting areas that we can talk about. Waldo et al., Fallacies of Distributed Computing. It's a fairly famous paper, but what it comes down to is basically you can't just ignore the distributed nature of a system from the beginning. The old idea that I could build some objects and then just distribute them out, and Corba or DCOM would take care of the latencies and the failures was a complete fallacy. Services have really kind of grown up to address that. So with services, we're making the points of distribution where the network starts and stops, we're making that explicit. Okay, so we're addressing some of those issues. Serialization, as I said, has generally been a problem. So in the early days, the early RPCs, they're all basically, as long as it was C, then you're okay, and as long as you're Unix, you're okay. Corba had lots of problems in mapping their interface description language to different languages, and Java kind of killed it. Actually, when Java became popular, the bindings all broke. Same thing with SOAP. The reason, part of the early problems with SOAP and interoperability was because the binding of XML to the data structures didn't work very well. JSON, I think, has got a better match. So we've got better matches in JSON to common language structures such as object attributes, arrays, and maps, but it's still not perfect. Okay. So some of the things I think one of the things we can talk about at another event is interface contracts and how we specify schemas for our services. And I think a common thing that we see is that people over-constrain their services. And this is partly a problem with XML and the power that XSD gives you a lot of rope to hang yourself with, right? You can say, well, in my customer record, a phone number is mandatory because we need to know that there's a phone number there. But the problem is the validity of a document is not a function of the document itself, it's a function of the process that you're following through, okay? So I really like to talk about Postel's law, which is be conservative in what you send and permissive in what you receive. So if you receive a data structure that you don't know what a field means, you don't just drop the bundle and say, oh, I don't know this. You accept it and you carry on as best you can with that, okay? I guess one of the worries I have is there's a lot of people working on things like JSON schema and all of those things. I fear that they're reinventing a lot of the bad parts of XML in JSON. Okay, so what to consider from microservices? A lot of this stuff kind of harks back to Braden's talk, and so I'll skip through it fairly quickly. Coupling versus cohesion. Here I'm using cohesion in a slightly different way to how Braden talked. I'm talking about cohesion across microservices. So what microservices does is it takes the position of we want to go to extreme decoupling. Okay, there's always a trade-off between decoupling, making all of your services independent and standalone, versus the cohesion, making the system consistent across itself. It's kind of related to the CAP theorem as well, okay? So with microservices, we say we want each of our services to be standalone, and that might be design time standalone, database standalone, etc. But then you get this trade-off with, well, everything doesn't look maybe the same across all of my different systems. Databases, we end up potentially with lots of different systems of record, lots of different databases of record, and then we have to try and synchronize them in some way or coordinate the information in those. Some of the things a lot of people have talked about with microservices is where they've got shared libraries or shared code, the problems of distributing that shared code across the different teams who are doing the different microservices. So shared libraries and code change, how do we manage that? The desire to have everybody's code base separate versus the decoherence we get from just copy and paste, okay? Another thing is in the service interfaces itself. If I've got a domain model that includes a customer and address, and I've got 25 different microservices dealing with that, I want maybe 2 or 3 versions of how to create a customer and address. Maybe 1, but maybe that's unrealistic. I don't want 25 different representations of a customer and address. So how do we share that information, those data structures, without getting too much coupling between the systems? Okay. Service design, I think that's an interesting area. Granularity, how big is a micro? Is it lines of code? Is it throwaway? I think that causes a lot of questions around microservices, and to some extent they're probably peripheral. They're probably not an important question, but I think it's worth understanding. Hypermedia and HathiOS, yes, I like the idea. I'd like to see some more examples of it. I'd like to see I won't say standards, because we keep marching down the standards path and get disappointed. I like to see some best practices, some cohesiveness as an organisation, as a community, as to how we do hypermedia with services. Right, and then design first specification. So there's a lot of work that's been going around designing APIs and doing the design first. I think that's worth looking at and talking about. Development concerns, so continuous delivery. So somebody mentioned PACT. definitely want to know more about PACT, want to have people coming in and telling us all about consumer-driven testing. I shouldn't have said client. I'm showing my client-server roots there. Consumer-driven testing using PACT. Runtime environment. This is very interesting. So people say, oh, your microservices should just be Unix processors. Go, they like Go for building microservices because it's all, I create an exe and I just deploy it out there. That's a nice idea. I love Unix processors. But you know, a lot of people want to use traditional containers, JVMs, etc. A lot of people want to use things like Docker and PaaS. So how does that affect our decisions and our approach to microservices? And what effect does auto-scaling have on those kinds of decisions? Languages and frameworks. So what's good? What works well? I've heard people say, yeah, Go is good. Node seems to be very popular. Scala, not sure. Frameworks, so Netflix, if you go to Netflix GitHub page, there's this whole ecosystem of microservice-related software there. It's a wonderful ecosystem. But I'm sure, yeah, there's other things. So Spring released their framework 4.0 the other day, and they're saying, oh, brilliant, you can build microservices with Spring Boot, etc. We do a bit of work with Mule and API Kit around building services, whether they're microservices. Beauty is in the eye of the beholder. So there's various frameworks, and I'm very interested to hear people's experience with languages and frameworks around building microservices. Logging and visibility, very important. So the other big bugbear about microservices, when you've got lots of distributed services, managing them, monitoring them, understanding where failures occur, recovering from those failures is a big problem that people struggle with. We've actually been using this kind of logging and logging service framework for years and years and years. I've been using it on lots of distributed implementations where basically the idea is you generate a transaction ID and you pass that ID along the chain and you log that to a centralized point. We used to use logging services, but these days things like Splunk, things like the ELK stack that we like at Sixtree, allow you to, it makes it very easy to log things out, to log files, move those events, forward those events into NoSQL data stores where you can do the analysis. You can use things like Riemann to do inferencing over an end-to-end transaction. So I expect this particular state model to be filled out, and when I get to the end of that state model, I knew that it all worked. And if it didn't get there, then maybe something went wrong and I do some compensation or I raise a trouble ticket or something like that. So there's a lot of interesting experience and ideas to swap around how we achieve that level of visibility in these distributed systems. So coordination, a lot of people use orchestration in traditional SOA, so BPM processes, BPL, services calling services. So the microservices people, some people are saying, well, that's kind of bad, you're just recreating a spaghetti architecture in services. And we prefer doing choreography rather than orchestration. So whereas orchestration is, I do this request reply and then I do that request reply, it's a bit like the hokey pokey, you do 2 steps in and 2 steps out, and at the end of it, you finished your transaction. That creates very tightly coupled systems which might be brittle, which might not scale terribly well. Choreography is where individual services do their work and then they will flick out events signifying the status of that bit of work or the status of the system of record, and you collate those events together to understand the end-to-end state of your process. Right? So we get into event sourcing, event processing, message passing, message-oriented middleware, and those sorts of things. Okay, anti-fragile patterns. So Adrian Cockcroft, he did a really neat a presentation called Dystopia as a Service. I wrote about it on InfoQ, so if you Google that, you might see my article. So he talks about this cloud-native architecture where he's got microservices. How do you build a hugely scalable application like Netflix in an architecture which is ephemeral, which is basically broken, okay? The thing with AWS, the thing with cloud architectures, the machines under you are coming and going. They can disappear at any time. So he talked about the new engineering challenge is not to construct perfect systems, but to construct highly agile and highly available services from ephemeral and often broken components. And that part of the toolbox there is using microservices. It's using reactive APIs to handle asynchronous message protocols. Things like bulkheads, circuit breakers, etc. These anti-fragile patterns. So where anti-fragile comes from, Nassim Taleb, the guy who wrote The Black Swan, wrote another book in 2012 called Anti-Fragile. The idea of anti-fragile is we've got these fragile systems where if you pull something, if something goes wrong, it all falls in a heap. It's very fragile. We're very familiar with that in the IT world. An anti-fragile system is that if you hit it, if you flick it, if you punch it, it gets stronger, okay? And organic systems are anti-fragile systems. If I go for a run, I damage the muscles in my body, but that makes them build back stronger. And if I run often enough, I become Steve Austin, right? So that's the idea. That's the theory, yes. Some use cases. I want to hear use cases from people. A lot of the use cases we hear about at the moment are greenfields applications. We're building a new app, and it's all microservices, isn't it? Isn't it beautiful? What about brownfields applications? What about people who are building microservices which coexist with existing monolithic apps, with existing SaaS applications? How do they work together? I think there's different schools of thought here. Udi Dahan says, you keep your COTS systems separate, you build your microservices here, and you use events to keep them synchronized, right? Other people say, well, you wrap your microservices around your back-end monolithic applications. That's kind of two ends of the spectrum. How do we make a decision around that? What does it mean for the build versus buy equation? Okay. Remediation. So there's people who are taking legacy monolithic applications and they're gradually disaggregating them and turning them into microservices. They're doing that to get cloud-native architectures. They're doing that to get the scalability they need to support global consumers. We're working with a couple of people like that, and it'd be good to get some people coming in talking about those types of use cases. Distributed teams, Braden talked about that. I worked on a project a few years ago where we were doing a smart grid system. I won't say it was microservices, it was certainly service-oriented. And we had some parts of the systems being built in the US, some parts in the UK, some parts in Australia. And what we did is we designed the service interfaces as the domains, and then we said, right, you go off and build to that. We use the service interfaces as effectively our contracts for interacting between the different systems. Okay. So, summarising that, that's the future agenda. I'd like us to make this a monthly meetup. So if there's interest and if we can sustain that, having maybe the second Wednesday of every month, we come along, and I'd like to have people volunteer to talk about some of these things. Or if you don't want to volunteer and you know someone who can talk, then you please feel free to dob in others. But you know, we want to make this open, collaborative, lots of discussion. We're all on this road of discovery together. There's lots of things to talk about. Domain-driven design, languages and frameworks, DevOps, testing, anti-fragile, all of that sort of stuff. And if there's any further ideas to add to that list, then please let me know. So I'm going to publish this kind of thing in the Meetup blog, and let's all look forward to collaborating on that together. I hope I haven't gone too over time.
What time's they close?